So once again, welcome back to Power Plant Engineering. Today we are going to start our next topic, that is direct energy conversion. So quickly coming to the syllabus. Okay, so far we have completed this gas turbine power plant. Okay, so in today's class we are going to start direct energy conversion technique. So as you can see in our syllabus, different types of direct energy conversion techniques we have. We have solar cells, we have fuel cell, we have thermoelectric and thermo-ionic generator, and we have MHD generation. Okay, so one by one in the subsequent classes we are going to cover all these kind of direct energy conversion techniques. So you remember one thing, they will ask you write short notes on any of these energy conversion techniques. Okay, all these 5 techniques they can ask in the final exam. Okay, to write short notes on any of these 5 direct energy conversion techniques. So one by one we are going to analyze in the subsequent classes. The first thing is, what do you mean by direct energy conversion? Okay, so we have 2 types of energy conversion techniques. One is direct energy conversion and second another one is indirect energy conversion. As we know, according to first law of thermodynamics, energy can neither be created, energy can neither be destroyed, but it can transform from one form of energy to other form of energy. Okay, we cannot create energy, we cannot destroy the energy. Whatever the energy present in the current universe, that will be constant. We cannot create it, we cannot destroy it, but what we can do, we can transform it from one form to another form. So during this transformation process, based upon this transformation process, we have 2 types of energy conversion. One is direct energy conversion, that is there in your syllabus, we are going to study now. One more is indirect energy conversion. Regarding indirect energy conversion, we have already studied in our previous classes. Okay, so how I will tell you? First I will explain you what do you mean by direct energy conversion. Direct energy conversion means, suppose we have one type of energy. Let's consider we have sunlight or solar energy. So one form of energy, if we can able to convert to another form of energy without having any intermediate stage, then that kind of energy conversion is called direct energy conversion. For example, we have sunlight. If we can convert this sunlight directly into electricity, then that kind of energy conversion is called direct energy conversion. Very simple. Similarly, opposite to this one, indirect energy conversion. In case of indirect energy conversion, one form of energy is there. Okay, that form of energy we have to convert into some intermediate form of energy. After that, that intermediate form of energy will be converted to another form of energy. I will give you example. Just in our previous class we have discussed regarding gas turbine. Okay, open cycle gas turbine, closed cycle gas turbine, combined cycle gas turbine, like this we have discussed. So what happened in that gas turbine? So in the combustion chamber we are adding the fuel, we are burning the fuel. So what is present in the fuel? Chemical energy will be there in the fuel. Okay, so whenever we are adding the fuel, we are burning the fuel, the chemical energy of the fuel will convert it to heat energy. That heat energy will be transformed to the turbine. From the turbine we are getting mechanical work output. So that heat energy is one form of energy. Whatever the mechanical work we are getting from the turbine, that is second form of energy, and from that turbine we are adding or we are coupling some generator and we are getting electricity. So that electricity is third form of energy. Once again, we are getting the heat energy from the fuel, so that is the first form of energy. That heat energy is converting into mechanical work output from the turbine, that is second form of energy. And from the turbine we are adding some generator and we are getting some electricity. So electricity is third form of energy. So here you can see this heat energy is not directly converted into electrical energy. The heat energy is converting to electrical energy through some intermediate stage, that is called mechanical energy. So initially we have heat energy that is converted to mechanical energy, then mechanical energy converted to electrical energy. So this kind of energy conversion is known as indirect energy conversion. Okay, so regarding indirect energy conversion, we have steam power plant, whatever you can say, steam power plant, then nuclear power plant, gas turbine power plant, all these kinds of power plant comes under indirect energy conversion. Clear? So now in this class we are going to discuss regarding direct energy conversion. Okay, so in direct energy conversion, directly one form of energy will be converted to another form of energy without having any intermediate stage. Right? So we have different kinds of direct energy conversion techniques. So one by one we are going to discuss in this class. So first is we have fuel cell, next is Thermo Ionic generator, next is solar energy, next is thermoelectric generator and MHD generation. Lots of direct energy conversion techniques we have, but in your syllabus only these 5 types of energy conversion techniques will be there. Okay, so we are going to stick to this one and I think it will be enough for you. Okay, so what I have planned in today's class, we are going to cover fuel cell and thermo-ionic generator. These two things in today's class we are going to complete. Okay, so first we will see what is fuel cell and how a fuel cell will act. So once again I am telling you, all these 5 kinds of energy conversion technique, they can ask you as a short notes, either 5 marks or 7 marks, like that. They can ask you write short notes on fuel cell, write short notes on MHD generation, draw a schematic of thermo-ionic generator and explain its advantages. Like this, from any of these direct energy conversion technique, they will ask you long questions. Clear? So one by one we will complete all these things. So first thing is fuel cell. Okay. So this is how a fuel cell looks like. Okay. So first I will tell you what do you mean by a fuel cell. Fuel cell is nothing but a electrochemical device. So fuel cell is nothing but a electrochemical device. What do you mean by electrochemical device? It is a device where chemical energy will convert it to electrical energy, or the chemical energy that is present in the fuel will be converted into electricity. So that is nothing but a electrochemical device, like your voltaic cell, battery, all those comes under this category. Okay, so a fuel cell is nothing but a electrochemical device that combines hydrogen or any other kind of fuel. Okay, because most of the fuel will contain hydrogen. It can be hydrogen, it can be methane, it can be methanol, it can be ethanol. Okay, any of the carbohydrates we can take. Mostly in maximum fuel it contains hydrogen, so that's why we have taken the normalized things. So a fuel cell is nothing but an electrochemical cell, an electrochemical device that contains hydrogen or any other kind of fuel. Along with that, it contains oxygen also to produce electricity. Okay, so the chemical energy of hydrogen and oxygen will be converted to electricity directly. Okay, along with that, whenever this chemical reaction will take place, we will get some water and heat as a byproduct. Okay, you might have studied regarding exothermic reaction, endothermic reaction. So in this process, some heat energy will get generated or some heat energy will get absorbed. Okay, so in this process also, fuel or the hydrogen will react with the oxygen. In this process, the chemical energy of the fuel will be converted to electrical energy, and throughout this process we will get water and heat as a byproduct. Okay, now how this reaction will take place inside the fuel cell, now I am going to explain it. Okay, so I have drawn a schematic diagram of a fuel cell. So here you can see two things. One anode is there. What do you mean by anode? That is negatively charged ion, and one cathode is there. Okay, which is positively charged. So two ends we have. This is one end through which we are supplying hydrogen. Okay, or we are supplying any fuel, and it is having some one other end where we are supplying oxygen. Clear? Up to this clear? Now here we have some electrolyte. Okay, so one electrolyte solution will be there inside the cell. Normally we are taking potassium hydroxide, KOH we have taken. Okay, so and I have now what happened? I will show you how the chemical reaction takes place at anode and how the chemical reaction will take place at cathode and how we are getting electricity. So what you have to do is you have to analyze the diagram, clear, and you have to remember the reactions that will take place at anode and cathode. Okay, so I will show you the reaction also. So at anode means here, what happened? Here hydrogen is coming, so this hydrogen will be there. Okay, now what do you mean by what is the function of the electrolyte? The function of the electrolyte is it will oxidize the hydrogen. Okay, so here we have the hydrogen near the anode, we have the hydrogen. That hydrogen will combine with hydroxide, OH minus. Okay, this KOH will be break down into K plus and OH minus. Okay, by the help of some catalyst. Some catalyst is also there. Okay, that catalyst will be break down it into K plus and OH minus. That OH minus will combine with hydrogen, so H2 plus OH minus, and we will get water. Okay, and if we will balance this chemical reaction, okay, left side how many hydrogens are there? 2H2 means 2 into 2 4. Here 4 H minus, here 4 hydrogen, here also 4 hydrogen. So in the left hand side of the equation we have 8 hydrogen, in right side also we have 4 H2O, 4 into H2. So in right side also we have 8 hydrogen. So balanced. Left side how many oxygens are there? 4 OH minus, so 4 oxygen is there. In right hand side how many oxygens we have? 4 oxygen we have. Clear? So the equation is chemically balanced. Okay, now in this process we are getting some electron also, 4 electron also we will get. So what happened near anode? We are getting some electron. Okay, now what happened? This electron which is generated at the anode, that will flow through this circuit. This anode and cathode, these are connected one with a load, or we are putting some ball or something to get the electricity. Okay, so whatever the electrons generated at the anode, this electron will flow through this load to the cathode. And when electron will flow from anode to the cathode, in this process we are getting electricity over here. And that is our requirement. Here we have used the fuel, hydrogen fuel, and we have converted the chemical energy of the hydrogen fuel into electricity. Clear? This is the reaction that takes place at anode. Now coming to the cathode. Okay, at cathode what reaction takes place? Whatever the electrons generated at anode, that is flowing towards the cathode. So those electrons will be absorbed at the cathode. At cathode what is entering? We are entering the oxygen. So that's why you can see in the equation at cathode oxygen is there, plus I told you here some water is generated near anode. So that oxygen will combine with water and some electron is also flowing from anode to cathode. Those electrons will be absorbed at cathode. Clear? So oxygen is combined with water, also it is combined with the electron and it will produce hydroxide, that is OH minus. Now you balance this chemical reaction at the cathode. At left hand side how many oxygens are there? Here O2 means 2 oxygen and 2H2O means here also 2 oxygen. So 2 plus 2, 4 oxygen. RHS how many oxygens are there? 4 OH minus means 4 oxygen is there in the RHS also. So oxygen is balanced. Now come to hydrogen. Left hand side how many hydrogens are there? 2 H2 means 4 hydrogen. Right hand side how many hydrogens are there? 4 OH minus means 4 hydrogen. Clear? So this is chemically balanced equation. Clear? So whatever the electrons that is produced in anode, the electrons are absorbed by cathode. Clear? Now if we will balance these two equations, okay, so here you can see, here in LHS near cathode, in left hand side 4 electron is there, in anode right hand side 4 electrons are there. So 4 electrons and these 4 electrons will get cancelled. Okay, in anode left hand side 4 OH minus is there, in cathode right hand side 4 OH minus is there. So this 4 OH minus and that 4 OH minus will get cancelled. Okay, so whatever the remaining byproduct we got, 2H2, so I have written 2H2 plus O2 gives rise to, so in anode right hand side 4 water, in cathode left hand side 2 water. So 4 minus 2 we are getting 2 water. Okay, so that's why in the definition itself I told you, in this reaction as a byproduct we will get water and heat. So this is the proof. As a byproduct overall we are getting some water also. Okay, and we are getting electricity as well. Why? Because whatever the electrons that is generated at anode, that electron is flowing from anode through the load to the cathode. So if electron is flowing from anode to cathode or from one point to other point, then in this process it will produce electricity. So what we have done overall, we have converted the chemical energy of hydrogen or the chemical energy of the fuel to electricity directly without having any intermediate stage. And as a byproduct we are getting water and heat. Clear? So that is all about the working principle of fuel cell. Clear? So the complete note I will provide you in the group. What you have to write in the note? In the note you have to write what do you mean by a fuel cell. Okay, you have to draw this diagram, schematic diagram of fuel cell. Then you have to write 3-4 lines regarding this diagram. It contains an anode and a cathode. Okay, through one end hydrogen fuel will enter, through other end oxygen fuel will enter. It contains an electrolyte KOH, it contains some catalyst, okay, to oxidize the hydrogen or the fuel. Okay, like this you have to write. Next you have to mention the equation. You have to prove that water you are getting as a byproduct. That is all about the working principle. Now next is the advantages of fuel cell. The first thing is it is very environmental friendly. Okay, whatever the byproduct we are getting, that is water, we can reuse the water. That is very environmental friendly. Whatever the heat we are getting, we can use those heat for some other form of work output. Okay, so the byproduct of this fuel cell is very environment friendly. Okay, the operation is very flexible, durability is very good, and the maintenance is also very simple. Okay, so there will, and the next one is there will be no noise pollution. The system will work very smoothly. So there you will not get any kind of noise pollution from the fuel cell as well. These are some of the advantages of fuel cell. Next is application. So we have some domestic application of the fuel cell like battery and all. We have some automatic, we can use this in some automatic vehicles also. Apart from that, in various central power stations, we can have the use of application of fuel cell. And more efficiently, in Apollo 11, in that missile, they have used this fuel cell. Okay, and whatever the byproduct they have got from this fuel cell, that is the water, they have processed those water for the drinking purpose also. Now you are thinking how that water that is coming out from the chemical reaction you can use for a drinking purpose. But there are different methods to purify the water. One of the method is called reverse osmosis. I don't know whether you can know, whether you have idea regarding osmosis process or not. But there are certain methods by the help of which you can purify the water. So in Apollo 11 they have used this fuel cell. And from the byproduct, whatever the water they have got, after some processing, they have used those water as a drinking process. So you can analyze how efficient this fuel cell is. Okay, so that is all about the working principle, advantages and application of fuel cell. Clear? Now we will switch to our next energy conversion technique, that is thermo-ionic power generator. Okay, that is the second energy conversion technique. I told you we have total 5 energy conversion techniques. So second one is thermo-ionic power generation. So in quickly I will complete this thing. In thermo-ionic power generation, it is a device that converts the heat energy into electricity, one form of energy to electricity, by boiling the electrons from a hot cathode through a vacuum, a small space of vacuum, to a cold anode. Okay, what is the meaning of that? When we will come to the diagram, you can analyze. So this is a schematic diagram of thermo-ionic power generator. So here you can see this is the cathode. Okay, this is the anode. The temperature of this one will be exceedingly high because some heat we are providing to the cathode. And every body, every metal, okay, that will contain some electron. Okay, and there is a term called work function, by virtue of which the metal can be able to bind the electron inside its surface. So whenever you will supply the temperature, okay, and its work function will gradually decrease. Okay, now if we will sufficiently high temperatures if we will provide to the cathode, the electron will vibrate. It will come to the excitation state and those electrons will come out from the cathode. In between cathode and anode, complete vacuum is there. This gap will be very small. 1 meter or 0.5, sorry, 1 millimeter or 0.5 millimeter gap will be there between cathode and anode. Whatever the electron will come out from this cathode, that will strike the anode. Okay, and in this manner they will make a cyclic process. Okay, so the cathode, the electron will strike the anode. Okay, then it will go to the external load and again it will come back like this. A cyclic manner of motion of the electron will take place from cathode to anode. Okay, so whenever the electron will move from one point to other point or from the anode to the cathode or vice versa, we are getting electricity over here. So basically in a thermo-ionic generator, from the heat we are getting electricity. In the fuel cell, from the chemical energy of the fuel we have got electricity. But here from the heat energy directly we have got electricity. Okay, same thing I have mentioned here. A thermo-ionic generator, it contains a heated cathode and a anode separated by a small gap, or mostly it is vacuum. Okay, the electrical output circuit is connected between these two electrodes, or between cathode and anode. And some advantages means it is also noise free operation, very quiet, cost is low. Okay, there will be no moving parts or rotating parts. Okay, and it can operate at extremely high temperature also. Okay, so that's all about for today's class. I hope you got some idea regarding thermo-ionic generator and fuel cell. Thank you.